Hello everyone, today we are going to present our project, Predicting Formula One Race Podiums. This project goal is to estimate driver championship standing in 2026 season using a Bayesian network and historical data from 2024 to 2026 using the dataset of FastF1 from the GitHub repository. Our tool that we use is Netica, Python, and our dataset FastF1. This is prepared by Kem Inkapat and Partihan Liangkopkit. So in the part 1, we're going to understand how Bayesian networks work. So what is Bayesian network? Bayesian network can define in one sentence as a Bayesian network is a diagram of variables linked by cause and effect arrows where each link carries a probability. So the Bayesian networks have two things, which is structure and numbers. The structure is the picture of how variables connect each other, and the numbers is the probability of each node inside each situation. So the three main building blocks is the node, which is a variable in the problem, and the arrows or the edges, which connect from, for example, node A to node B. It means that A directly influences B. And the last one is conditional probability tables, which is a table that have the probability of each state of every combination of its parents. For our example, I'll use the example of does it rain today? So from the structural diagram, it has three nodes, which are rain, wet grass, and umbrella, with two arrows coming from rain to wet grass and rain to umbrella. Without any evidence, the bars or the probability of each network is according to its current belief about each variable. How a Bayesian network answers questions? So we have to enter the evidence and then read the results. For example, if we observe that someone has an umbrella with them, the rain becomes much more likely to happen. For this diagram, the rains jumped from 30% to 85% with umbrella observed. Now we're going to apply this into our Formula One problem. This is the problem that we designed. The prediction question is that given what we know about drivers and teams from previous year and current year performance, what will their championship standing be? So the situation here is that in the middle of the 2026 season, multiple races has been finished, but clear winner or standings of each driver still doesn't show. What do we do? So our variables that we have is the team legacy, which is how strong of the team or car is. Expected race pace is the average finish of period race. Reliability, the reliability of driver in current season. The driver skill, the driver's recent results form. Why Bayesian networks fit this problem? It is because the outcome is uncertain, which is the probability, and the clues are connected with the four clues that we have said before. They are all connected to the podium. It reasons both ways. Given the causes, it predicts the result, which a flat formula or single rule cannot do. This is the design of the network that we did. So we have 5 variables, which 4 clues that we have from the problem, which are the driver skill, team legacy, reliability, expected race pace, and the target outcome, which is championship standing. And our arrows is the arrow from driver skill to expected race pace, an arrow from team legacy to expected race pace, and the arrow from expected race pace to championship standings, and reliability to championship standings. And this is the method how we build it step by step. So firstly, we get the data from FastF1, and then the second, we discretize it to make the raw numbers into categories. Then we build a structure that we designed in the previous slide, which we will have 5 nodes and 4 arrows in Netica by drawing. And fourth, we add the conditional probability distribution or conditional probability tables to each node's probability table. And fifth, we run inference by entering a driver's evidence and read the championship standing probability to predict the result.
And now let's talk about the component of our network. Start with the conditional probability table. So the first one is a driver skill, which we try to categorize the point per finish of the driver in the previous season into low, mid, good, and elite driver. Then we got the team legacy, which translate to how they make a performance car on not so performative car. So we got the backmaker, the top tier, and the midfield team. Another one is the reliable of the driver. So we use both season of the previous season and the current season. So we want to know either the driver is still reliable to the current season, and then the expected race pace, which the average finish position of the driver, which got many value because it is the intermediate node. And then the last one, the championship standings, which show the distribution of the standings of each driver. So it got many value also because it's the final node that has 2 parent nodes. So as I mentioned, this is how our final network will look like. And then if we know nothing about any driver and we use just the distribution of every value, we can see that there's a 26% chance of the driver to be on the podium or on the P1 to P3 in the championship standing for the results after the season end. Then about 33 to 34% of the driver being P4 to P10 or on the top half, and then about 40% to be on the bottom half. But we try to play a little with the values we got here. So if we imagine that our driver is the elite driver on the top tier team, which the expected race pace about P1 to P3, and he's a solid driver or he's very reliable, he's likely to be a champion or on the top 3. As we can see, about 66% to be on the top 3. Then what if the driver is on the elite side on the top tier team, very reliable, but he's about P4 to P10 or on the middle of the table of the ranking? He would likely end up on the middle tier or P4 to P10. And what if we categorize the driver as a fragile driver, which we say that he's not very reliable on the form, so the result would equal throughout the values because he's not very reliable, so we couldn't count on him very much. And then we try to play with the values the driver skill. The low driver skill tends to be on the lower on the championship standing, and the higher driver skill tends to be on the higher side of the ranking also. And then we want to know that if we use the 2026 season data to the last season, and also I'm watching F1 constantly, so I think I have a little bit of idea of how each driver will be. We take the first one, Norris, which is the 2025 season winner. So he sits on the elite side. He's a top tier team, but the current form, he constantly on the P4 to P10, but he is a solid driver, so he might be on the middle tier or P4 to P10 on the championship standing. Also on the PF3, which from the same team and the second runner-up from the last season. He is not very solid driver. He's not reliable from the 2025 to 2026, so we couldn't count on him as much. Then the Verstappen, the fan favorite, the first runner-up from the previous season. As from the current form, he is not really on the top. He is about P4 to P10, so we could hope he is on the top tier or the middle tier, P4 to P10 on the championship standing. And lastly, Antonelli, which is a young prodigy that performed really well on the season. So he's the most likely to be on the top on the P1 to P3. So I think that's kind of explain itself and capture the pattern very good as F1 fans. So I kind of like this project. And so what do we get from this network? So the expected race pace is like the most influential variable that would affect the championship standings. Also, the car strength matters that indirectly, like each team, like the performance of the team would also affect the championship standings. And the reliability really helps strengthen the belief. So if we know that the driver is solid, we could be sure. But as we can see on the fragile side, sometimes the distribution comes really unclear. And also we need to take note that the result is not a prediction, it's just an explanation to capture some patterns that occurs in the statistic way, in the Bayesian way. So yeah, just look at it not as a prediction, but it's an explanation. So in summary, we define a clear problem. At first, we use the model that we think it fits our use, and the result kind of makes sense in the current situation. But I think if we proceed on the project, we could expand the dataset. But for right now, I'm really happy about this project, and that's it for our presentation. Thank you.